Okay, 5.2 is called special products. It's the same thing as 5.1, but if you can recognize that a special product exists, you can move much faster. So if you don't know 5.2, you're good. You can still do the 5-point way method, which is multiply everything by everything, simplify, whatever. This is just a shortcut when it's available. And you kind of need to know when it's available, because when we go backwards, it's really, really time saving if you know what a special product is. So there's two types of special products, and they're so similar that a lot of mistakes come from the fact that they're similar and you confuse them. One is a perfect square. Guys, perfect square is like 5 squared. It's the same number squared. So x plus 5 times x plus 5. This is a perfect square because it's the same dimensions multiplied by each other. Difference of squares, you don't really know why it's called difference of squares now, but it is not the same dimensions multiplied by each other. They differ because the signs are different. Nothing else is different. X plus 5, x minus 5. Everything is identical except one is plus and one is minus. It does not matter which comes first, plus or minus. Okay? Perfect square, signs are the same, numbers are the same. Now take a look. If we do 5.1, what happens here? I'm going to expand this, x times x, x squared, x times 5, 5x, 5 times x, 5x, 5 times 5, 25. So I can still do this like 5.1. But look what happens in the middle. The middle is always going to be the same number because they're the same numbers. So remember when I did inside and outside yesterday? It's always going to be 5x and 5x. So really all you have to do is just multiply these two together and double it. X times 5 is 5x, doubled is 10x. So my answer is x squared plus 10x plus 25. Might be a little confusing what I just said right there. But when I have a scenario where I have a square like this, we can move faster, and I'm going to do this example right now because we just saw it. We can move faster by understanding that the first term is going to be the first number squared. The last term is going to be the second number squared. And for the middle term, instead of thinking inside and outside and writing it down like that, it's a waste of a step, you just multiply these two numbers together. X times 4 is 4x. Double it and put it in the middle, 8x. And in one line, one step, zero thought almost, besides that multiplication and double, I can get my answer. It's really easy. Like, take a look at this. K squared, positive 25. You can't have a perfect square unless that number's positive. Okay, so that's important. Negative 5 times negative 5 is positive 25. In the middle, negative 5k doubled is negative 10k. So special products allows me to not do this. Saves me some work. Okay, now I got numbers in front of letters. I got second letters. No problem. The first thing squared is 9y squared. The second thing squared is 49x squared. So I always squared for the outside numbers. And in the middle, 3y times 7x is 21xy, doubled, 42xy. And I'm done. Try your best to do it in one step. It's going to come in handy when things get more difficult. Do it this way at first, but please try it this way. Okay, now, the second type is difference of squares. Look at the difference when we expand. X times x, x times negative 5, 5 times x, 5 times negative 5. I still got that doubling happening in the middle, but the signs are different. So I'm only doubling here because the signs are the same. Whereas over here, because the signs are different, they actually cancel to 0. Always. They always cancel to 0. And I'm left with just x squared minus 25. Notice how this is not positive because the signs are always different, and if I'm multiplying signs that are different, it's always negative. So that can't be positive. And this right here, this is a difference of two squares. X squared is a square, 25 is a square, and that's a different sign. That's the difference of squares. Okay, so this makes more sense understanding difference of squares than it does here. But anytime you see things that are the same with different signs, all you have to do, it's actually easier than that because there's no middle term. Square the first number, square the second number, slap a negative sign in the middle, move on. Let's take a look. Q minus 11, Q plus 11. Ooh, they're the same, different signs. Done. Q squared 121 minus sign. Done. Right? Because the middle term is a 0. I know it's always going to be a 0 because I understand difference of squares. Let's take a look at this one. 4m plus 3m times 4m minus 3n. Everything's the same. Signs are different. No problem. 16m squared, 9n squared, minus in the middle. Done. Okay, now, when you see difference of squares, you should be drooling because it doesn't get easier than this. It's a maximum shortcut, minimal writing, minimal ink wasting. So you always look for difference of squares and perfect squares because the speed at which you can move at is very quickly. So if you don't train your brain to think about finding them, and in 5.2 it's going to be easy to find because they're all special products, but later on they're going to be hidden in problems. And the guy who discovers that it's a special product, way less work to solve a very complicated problem. Not just a problem like this, but they become more complicated. Okay, and that's it. 5.2, you can know it, you can not know it. One moves faster.